Inshallah, in today class, we are going to start linear differential equation of higher order. Linear differential equation of higher order. I'm not going in detail the concept because the video will become too large. The main concepts, the main things I wrote to start the problems. Okay. So an ordinary differential equation, an ordinary linear differential equation of higher order. An ordinary linear differential equation of higher order is of the form d power n y plus p1 d power n minus 1 y plus p2 d power n minus 2 y2 plus p3 d power n minus 3 y so on plus pn yn equals to q of x. This is the general equation of linear differential equation of higher order, where d means d by dx. D is the symbol notation for d by dx, and p1 p2 p3 so on pn are real constants. P1 p2 p3 p4 so on pn are real constants, and q of x, that is on the right side, q of x is a continuous function of x. Now see here, there are some things, watch carefully. Suppose the solution of f of d equals to y equals to 0. If y equals to yc is the complete solution of f of d of y equals to 0, and y equals to yp is a particular solution of f of d into y equals to x, then the complete solution is given by y equals to yc plus yp. I'll I'll explain this detailing in question. When we are doing the question, inshallah, you can understand this. Yc is called the complementary function, and yp is called the particular integral. We will understand this clearly in the questions. Okay. So the one more thing is auxiliary equation. Y equals to e power mx is a solution of f of d into y equals to 0. Y equals to e power x is a solution of f of d into y equals to 0. This is the equation obtained by replacing d by m. When we change d by m, the equation is called auxiliary equation. That is f of m equals to 0. When we keep in place of dm, when we change d by m in the equation, then the equation f of m equals to 0 is called auxiliary equation. Now let we discuss the how many types of complementary equations will be there. Complementary functions we'll discuss. Now this topic is very important topic. This topic will be used till end of the chapter, so you must by heart these things. You keep all this in your mind. Okay. Now how to find the complementary functions? How to find the complementary functions? I'm just showing you the answers, the methods. Okay. We are not going in detail the concepts. You see, if all the roots of auxiliary ratio are real and distinct, means different. Suppose we get the values of m on solving different values, suppose 2 comma 3 comma 5, like this, different values, not equal values, not same values, not repeated values, but different values, distinct values. Then we have to use this formula. Suppose we are getting m equals to m1 m2, two different values, then complementary function formula will be yc equals to c1 e power m1x plus c2 e power m2x. Suppose we are having three different values, m4 or so on, m1 m2 m3 m4, then the complementary function formula will be yc equals to c1 e power m1x plus c2 e power m2x, similarly c3 c4, like that. For different values, if we get the values of m as different distinct values, then this formula. And the case 2 is when we get the m values equal, real and equal. If the m values are repeated, suppose for instance m equals to, we got 2 comma 2, or suppose we got m equals to 3 comma 3 comma 3. When we get the values of m same values, then we have to use this formula. Suppose we are getting two values same, then we use the formula. Complementary function is yc equals to c1 plus c2x into e power mx. If we get two equal values, we will not show m1 m2 because both are same, therefore both are m and m, denote m and m. So if two values are same like this, then we have to use the formula c1 plus c2x e power mx. If three values are same, then we use the formula c1 plus c2x plus c3x square e power x, and so on. If four values means plus c4x cube, like that. So for same values, if the auxiliary equation have repeated roots, then we use these formulas. And lastly, one more concept is here. if the roots of auxiliary equation are complex and imaginary, like this. Suppose alpha plus or minus I beta, like this. 2 plus or minus 3i, 1 plus or minus I. So if we get complex, if we get I imaginaries, then the formula will be yc equals to e power alpha x. Yc equals to e power alpha x into c1 cos beta x plus c2 sin beta x. c1 cos beta x plus c2 sin beta x. So my request is you write this all complementary function methods, three cases. For distinct, what is the formula you see? For equal roots, repeated roots, what is the formula you see? And for imaginary, you by all this. Let me start the questions based on this type of questions. So you must, before going in the questions, I request to first go through these formulas. These formulas we have to use in the coming questions. Now you see there is a question on the board. Let me start the question. Solve. You see d by dx we can write like this, capital D cube. Let me take y common from all. This is capital D cube minus 7 into d by dx we can write capital D minus 6 whole bracket into y equals to 0. We can write like this, d by dx is capital D cube minus 7 d by dx is capital D minus 6 into y. Now let me write the auxiliary equation. Auxiliary equation is, in place of d you write m. In place of d you write m. This will become m cube minus 7m minus 6 equals to 0. So this is a cubic equation. We can take directly this from the calci. No need to solve all the things. Let me take this from the calci. How to take from the calci? First go into mode. We have taken mode. Then the fifth number is equations. We have to go into the equations. Now this is a cubic equation. This is a cubic equation. The cubic equation is fourth one. Okay, let I explain you. This is of the form ax cube plus bx squared plus cx plus d equals to 0. So a is 1 here. A equals to 1. Now there is not m squared, not m squared here. So the b will be 0. C equals to minus 7 and d equals to minus 6. So let me substitute these values in the calculator to get the values. First a, the value of a is 1 equals to, b value is 0 equals to, and the c value is minus 7 equals to, d value is minus 6. Now you will get the values of m. So we'll get the values of m equals to 3 comma minus 1 comma minus 2. Because it is cubic equation, we'll get 3 roots. Because it is cubic equations, we get the values. Let I close this. Okay, watch here carefully. Now there are 3 values. Now these 3 are different. So case 1, case 2, case 3, just now we have seen. This is for case 1, 3 different values. Therefore, complementary function is yc equals to c1 e power m1x plus c2 e power m2x plus c3 e power m3x. So let me substitute the values. C1 e power, suppose this is m1, so 3x plus c2 e power m2x, minus 1x is minus x plus c3 e power minus 2x. You see, watch carefully. When we have equals to 0, we don't have any particular integrals. Equals to 0 means we don't have any particular equations. We don't have any particular equations. We don't have any particular equations. So this is the answer. Only complementary function. Therefore, the solution is y equals to c1 e power 3x, c2 e power minus 3x. Now see here the next question. I wrote 3 steps. This is d cube minus 3d square plus 3d minus 1, taking y common. So auxiliary equation means in place of d you write m cube minus 3m square plus 3m minus 1 equals to, leave this one. So if you go in calci, you see here, this is the cubic equation. So for cubic equation, the coefficients are, first the coefficient is 1 equals to, then minus 3 equals to, 3 equals to minus 1. So the answer you should get x equals to, how many roots must get? We must get 3 roots, m equals to 1 comma, but it is showing only 1 root. If you go in this calci, whatever the calci I'm using, this calci, this is fx991 es plus. So in this calci, when the roots are repeated, it will not show all the roots. We have to imagine, because this is cubic root, we must get 3 roots. But cubic root means we must get 3 roots, but the calci is showing only 1. That means this 1 is repeating 3 times. This one is repeating 3 times. So let me see which case. First case are distinct roots, second case are equal roots. So these 3 are equal roots. So we wrote the formula complementary function is yc equals to c1 plus c2x plus c3 x square e power mx. So let me write the value c1 plus c2x plus c3 x square e power m is 1x means x. So when the roots are repeated, we have to use this formula. When the roots are repeated, we have to use this formula. Now see here the next question. The next question. Solve y 4. This is d cube. 4. This is d square. This is d. Whole you take y common equals to 0. Now the auxiliary equation is 4m cube plus 4m square plus m equals to 0. Either you solve by yourself or you take the values from the calci. We'll get 3 values. Now I just want to show how to take the answer. Because these two values are equal, this is case 2. But this is different, for this is case 1. So let me write the, watch carefully, complementary function is y equals to, since these two are same, I am writing this c1 plus c2x e power mx. For 2 equal, we wrote this formula. For 2 equal, we wrote this formula. This is another, let us continue this one, c1, c2, this will be c3 e power, let it be m1x. These two are equal. No, for 2 equal, we wrote this formula. I just go through the formulas. And this is different, so continue this one. So let me write now. C1 plus C2x e power mx. M is minus 1 by 2x, that is minus x by 2. Plus C3 e power m3x, 0 into x. Any number power 0 will be 1. So this is 1. You can write like this. C1 plus C2x into e power minus x by 2 plus C3. Now you see the next question. I already done this just to reduce the time of the video, because if you go lengthier, the video will become lengthy for you. So I'm just writing short. You know the auxiliary equation is m square minus 6m plus 13 equals to 0. If you solve from the calc, you'll get the value of m equals to 3 plus or minus 2i. Now this is case 3. Case 3 is complex roots. For complex roots, we wrote the formula m equals to alpha plus or minus I beta. The complementary function is y equals to e power alpha x into c1 cos beta x plus c2 sine beta x. Now let me see here what is the value of alpha. Alpha is 3 here, beta is 2 here. Alpha is 3, beta is 2. Now let me substitute these values. Y equals to e power alpha x. Alpha is 3, we are having 3. So this will be 3x to c1 cos beta x. Beta is 2x plus c2 sine beta x. Beta is 2x. So this is the answer. Now see in the board, on the board, what the equation we have, d square plus d minus 2 of y equals to 0. So auxiliary equation will be m square plus m minus 2 equals to 0. When we factorize this one or you take from the calc, you will get the values of m1 minus 2. So these two values are different. So with the case 1, the formulas of case 1 is c1 e power m1x plus c2 e power m2x. So we get these values. Now from here, I will show the method. Okay. Here you see here, the more, what is the condition given? Y of 0 equals to 4, y dash of 0 equals to 1. Whenever you see like these conditions are given, that means using this, we have to find c1 and c2. Whenever these conditions are given, using these conditions, we have to find c1 and c2. What is the first condition you see here? This is the first condition, y of 0 equals to 4. That means when we keep x value 0, the y value is 4. This means x value is 0 and y value is 4. This is x. This is x. That means y of 0 equals to 4 means when we keep x equals to 0, the value of y is 4. That is, in this equation, you keep x value 0, y value 4. X value 0, y value 4. So let me change. Y value is 4 equals to c1 e power 0 plus c2 e power minus 2 into 0. Any numbers power 0 is 1. This is also 1. Therefore, we get one equation. C1 plus C2 equals to 4. C1 plus C2 equals to 4. What is the condition next one? Y dash. But this is y. When we differentiate this one, we will get y dash. So first let me differentiate and take this condition. Y dash means differentiation of this. Y dash means differentiation of this. Let me differentiate this. Y equals to C1 e power x plus C2 e power minus 2x. Let me note this as 1. So let me continue here. First, let me differentiate this one. let we continue. Let first we continue this one. Okay, see here we have to differentiate this one. If we differentiate this one, y will become y dash. See here e1 as it is, d by dx of e power x will be e power x only. Similarly, plus c2, d by dx of e power minus 2x will be minus 2x. But d by dx of, suppose we write like this, d by dx of, again we have to differentiate 2x. So x will be 1, 1 into minus 2 will be minus 2. D by dx of minus 2x, again we have to differentiate this one, minus 2x will get minus 2. So I am writing this here minus 2. Okay, d by dx of e power x, d by dx of e power x is e power x, but minus 2x differentiation minus 2 right here. So now let me use the condition y dash of 0 equals to what is here 1. That means when we keep x equals to 0, y dash is 1. That is x equals to 0, y dash equals to 1. Now let me substitute this here. Y dash is 1. So 1 equals to c1. E power 0 will be 1. No need to write minus 2c2. E power 0 will be 1. So this, let me note this one as 2. Now first one we are having c1 plus c2 equals to 4. And second one is c1 minus 2c2 equals to 1. Now let me solve this one. We'll get the, let me cancel this one, minus, subtract this one. This will become minus, this will become plus, this will become minus. So plus c1 minus c1 cancel. 2c2 plus c2 will be 3c2 equals to 4 minus 1 will be 3. 3 by 3 1. So c2 equals to 1. C2 equals to 1. Let me write here. Now substitute C2 here, you will get C1. C1 plus C2 equals to 4. C1, C2 we got 1. C2 plus 1 equals to 4. Sorry, C1 plus 1 equals to 4. C1 equals to 3. So we got C1 equals to 3. C2 equals to 1. Let me substitute this in the final answer. What is the answer we got? C1 e power x plus C2 e power minus 2x. Now let me substitute the values of C1, C2. C1 is 3. So this will be 3 e power x plus C2 is 1. 1 into C, E2 will be E2 minus 2x. So what we have learned in this, whenever the conditions are given like this, y dash of 0 or y of 0, that means using that conditions, we have to find the constant C1, C2, C3. Now see here the next question. Y triple dash means d cube minus 5d square plus 7d minus 3 into y equals to 0. These conditions later we will use to find the constants. Okay, now start this auxiliary equation. I just want to show the auxiliary equation. Now we have to solve this using, let me solve this using calci mode, then equations number 5. This is cube equation number 4. Let me substitute the values. Coefficients are 1 equals to minus 5 equals to 7 equals to minus 3. So we must get three values. The first value is showing as m equals to 3, comma. Next value is showing as 1. Only two values are showing. The calci is showing only two values. The calci is showing only two values. But this is cube equation. For cube equation must get three values. So that means the second value, the method is here, watch carefully. When the calci is showing only two values, that means the third value is repeating. Must get three values. The second value is repeated one. That means the calci is not showing. This calci, this fx991 will not show the repeated root. So we have to understand that the second root will be always repeating. So this is 3 comma 1. Then when you must take one more value of m as 1. I am writing this like this, m equals to 1 comma 1 comma 3. These two are same. Therefore for this complementary function is y equals to two same values c1 plus c2x into e power mx. For two equal values we have this one. One more value is there. Now for that let me continue c3 e power m1x. Now let me substitute the values. So we get y equals to c1 plus c2x e power m is 1 here. M is 1. 1x means x plus c3 e power m1 let be 3x. So now we got the values. Now let me use the values. First one, y of 0 equals to 1. Then we have to differentiate and use y dash of 0 equals to 0. Then again we have to differentiate y double dash of 0 equals to plus 5. Using these three conditions, inshallah, we'll get c1, c2, c3. Then we can substitute the values to get the final answer. So let me note this as 1. Now let first we use y of 0 equals to 0, y of 0 equals to 1. That means this x equals to 0, y equals to 1. That means x equals to 0, y equals to 1. Now let's substitute this one, y value 1. That means this is 1 equals to y is 1. E power 0 will be 1. 0 into c2 will be 0. So just left is c1. C1. This is 0. x is 0, 0 into c2 0, e power 0 is 1. So we let from e power 0 will be 1, 1 into c3 c3 plus c3. That I am noting this as equation 2. Now the next condition what is given here, y dash of 0 equals to 0. That means when we differentiate, after differentiating one time, the x is 0, y is 0. Let me start differentiating here. Differentiate now. Differentiate. When we differentiate, this y will become y dash. Now these two are multiplying, so we must feel this is u, this is v. Must take this u and this as v. We know what is the differentiation of u. U d by dx of v plus v d by dx of u. Watch carefully. U means this one, u c1 plus c2x, u d by dx of v. D by dx of e per x will be e per x. U d by dx of v plus v. Plus v means e power x into d by dx of u. When you differentiate this one, this is constant 0, and the differentiation of x will be 1. 1 into c2 will be c2. You will get c2 here. See once more. These two are multiplying, so you differentiate by using uv. U d by dx of v, d by dx of e per x, plus v means e per x, d by dx of u. When you differentiate, this is constant, you don't have x here, 0. D by dx of x is 1, 1 into c2 will be c2. Got it? Now next continue, let me. So c3 as it is, d by dx of e per x is e per x, e power 3x. D by dx of e power x is e power x, e power 3x. But when we differentiate 3x, the x is 1, 1 into 3 will be 3, you get 3 here. Now let me use the formula. What is the value I? X is 0, y is 0, y dash is 0. Suppose let me substitute this, x equals to 0, y dash equals to 0. Y dash is 0, x is 0, so this becomes 0, e power 0 is 1, 1 into c1 we get c1. X is 0, e power 0 is 1, 1 into c2 we get c2, plus this is 0, 3c3. Let me denote this as equation 3. Now one more time we have to differentiate. One more thing is given, y double dash of 0 equals to minus 5. That means we have to differentiate one more. So let me differentiate this again. If we differentiate y dash, we denote by y double dash. If you differentiate y dash, it will be y double dash. Y double. Again uv, just we have done now, u d by dx of v means e power x plus e power x. Now d by dx of u, this is 0, x is 1, 1 into c2 is c2. C2. Again, this differentiation will be same, c2 e power x. We can write 2 now. This plus this 2 e power x is c2. Plus, if we differentiate this 3 will come here again. 3 plus 3 into 3 will become 9 into c3 e power 3x. E power 3x. Now let me substitute the values. No, let me substitute the values. What is the values? X is 0, y minus 5, y dash minus 5. So y dash minus 5, that means this is minus 5 equals to x is 0, e power 0 is 1, 1 into c1, c1 plus 2 c2 e power 0 is 1 plus 9 c3. Let me denote this as 4. Now we are getting three equations here. The first equation is like this, c1, you don't have c2, you write 0 c2 plus c3 equals to 1. This is equation 2. Now equation 3 is c1 plus c2 plus 3c3 equals to 0. This is equation 2. Now equation 3, sorry, equation 2, equation 3, equation 4. Equation 4 is c1 plus 2c2 plus 9c3 equals to minus 5. So let me solve this one. When we solve this 2, 3 and 4, we'll get the values of c1, c2, c3. No need to worry because we can use the calci. We can use the calci. Let me use the calci. You see here, first you go in mode, we want equations number 5. Now see here, this is actually 3 variables equation, x, y, z. c1, c2, c3 is nothing but 3 variable equations are number 2. The second equation, a and x plus b and y plus c and z equals to dn. So we have to take the second equation. Now what are the coefficients? 1, 0, 1, 1. So we write 1 equals to 0 equals to 1 equals to 1. So next equation is here, we can use this one, 1, 1, 3, 0. 1 equals to 1 equals to 3 equals to 0. Now lastly here we have to use this one. This is 1, 2, 9 minus 5. 1 equals to 2 equals to 9 equals to minus 5. So let me get the answers. So we are getting the first value, that is c1. c1 equals to 2, c2 equals to 1 and c3 equals to minus 1. So let me substitute these values in the equation. What the equation we are having? Equation 1 is y equals to c1 plus c2x e power x plus c3 e power 3x. Now let me substitute the values. Y equals to c1 is 2 plus c2 is 1. 1 into x is x e power x plus c3. c3 is minus 1. So minus 1 into this will be minus e power 3x. So we got this answer. So let we continue in the next class, inshallah. Whatever we have done, you practice, inshallah. In the next classes also you will get to like this questions solving of complementary equations. If new questions are there, inshallah we will solve later. Okay, so I request all our students to like this and subscribe this and share my channel, inshallah. We are going to continue in the next part 2, inshallah.